Hello, my favorite calculus class. This is Miss Letchworth again, and we're going to start the third major part of calculus today. Remember, I've always told you there are three major parts. The first one is limits, the second one is differentiation, and the third one is integration. Integration is going backwards from differentiation. When we integrate, we get what is called an antiderivative, because when we differentiate, we get a derivative, and this is the opposite of that, okay? We're also going to talk about indefinite integrals, okay? And everything that we do for right now will involve an indefinite integral, which means that when you see this crazy-looking cane-looking symbol, then that refers to an indefinite integral unless you see numbers on it. Sometimes you'll see like from 3 to 7 like that on an integral, and that's what we call a definite integral. So if you don't see the numbers, then that is an indefinite integral. And the two are used for different things in calculus, okay? So for what we're going to do today, we're going to be doing an indefinite integral, okay? So here is your power rule for integration, and it goes backwards from your power rule for differentiation. You know, if you were differentiating the power of x to the n, this is not the end, not yet, getting there though, all right, you know that you would actually take that power and multiply it by what's in front of x, and then decrease your power by 1, right? So what we're going to do here is we're going to do the opposite thing, all right? When you integrate x to the n dx, okay, that means that this is the derivative of y with respect to x, okay? Then you are going to actually add your 1 back onto n, and then you're going to divide by the n plus 1, whereas you were multiplying over here, okay? So that goes the opposite. Now, big thing is plus c, okay? So what exactly is plus c? I am so glad you asked. Plus c is some constant that would have been on your derivative, okay? So like I said, all right, instead of taking the derivative, what they're doing when we integrate is this is actually the derivative. You're integrating it back to see what f of x was. So this is technically f prime, whereas what you're getting right here is f. So the reason why we do the plus c is because there could have been a number over here on f that when we took the derivative of it, we got a 0, because technically this could be written as x to the n plus 0. And see, we don't know if it was there or not. If it wasn't, that means c is 0. But c could be some constant number, okay? Now that may not make a whole lot of sense until we get into doing what we refer to as a particular solution. But for right now, just remember, plus c is a biggie, and it could cost, let's see how much money this is going to cost you on the AP test. Cha-ching, cha-ching, cha-ching. It could cost 1 or 2 points on an FRQ. That is a lot of money, you guys. That's a lot of points because you only get 9 points on an FRQ. You don't want to lose 1 or 2 points just because you forgot plus C. I've actually seen it more than 1 or 2 points, to be quite honest with you, okay? Plus, you can't, on the FRQs, really, if you forget the plus C, you can't really go too far, much further anyway, okay? So always remember that plus C. So I can tell you what it's going to cost in Miss Letchworth's room. Oh, Lord, let's put some more money up here on the table. How much is it going to cost in Miss Letchworth's room? It's going to cost a lot more than that. It's going to cost you half credit. That's how important it is that you put that plus C. All right? So make sure you put the plus C. It will make sense to you as we go along as to why it is so important. Okay? It may not at first, but it will, okay? All right, so second thing here is no page 244 in the gray box that's in your textbook, okay? In one column, it lists your differentiation rules that you've learned so far this year, and in the second column, it lists the integration rules that go along with the same kind of function, okay? So that is a really good page. You're going to want to bookmark that page, okay? Put a little sticky note there or something, but bookmark that page. It's going to come in handy, all right? So let's see how we're going to use that power rule on these two problems right here, okay? So here is my integral, okay? So that symbol right there is called an integral. And we're doing the integral of x squared dx. That means that x squared is your f of x. So this is f prime, and what we're going to do is we're going to figure out what f of x was, okay? So we're going to we're going to say that capital F of x. I don't know why your book likes to use capital F of x. I won't be picky over that, okay? But it's really just f of x, okay? But capital F of x is your antiderivative. In other words, it's just f of x, and this is f prime, okay? So capital F of x is x to the second power, okay? We're going to add 1 to that, and then we're going to divide by 2 plus 1. Then we're going to put our plus c. We're going to simplify everything. And that gives us x to the third divided by 3 plus c. Now, how can you check that? Go backwards. Take the derivative of this and see if you get x squared. And you would, because if you took the derivative, if you drop this down in front and decrease that power by 1, look at what you end up with, x squared. And then here you go. The derivative of any constant number would be 0. So do you see why we put the plus c now? So you can actually check that answer to make sure that you got it right just by going backwards, okay? All right, let's try this one, okay? Technically, what you could do if you wanted to is you can look at 3 as a scalar because that's your coefficient, and you can pull that through your integral. And then you can just integrate x cubed, okay? And again, the way that you integrate x cubed is we're going to add 1 to our exponent and then divide by 3 plus 1. So what I end up with is, bring this 3 down. I'm sorry, I really should have put my capital F of x. Bring this 3 down. And then this becomes x to the 4th over 4 plus c. Okay? All right? Now, let's complicate matters because, you know, calculus just isn't fun unless we can throw a lot of crazy algebra in there and complicate some stuff. This actually isn't crazy algebra, okay? But all the way through limits, all the way through differentiation, I always told you, simplify your problem before you take a limit. Simplify it before you differentiate it. Simplify it before you integrate it, okay? So right now, the only rule you know is the power rule. You don't know a product rule or anything like that. Well, that's because there's really not one for integration, okay? There's not a product rule, okay? But there are other integration techniques we'll discuss later. But right now, the only thing you know is the power rule. So multiply this out, okay? Simplify the problem. I'm going to make this x cubed plus 3x dx. So there's your derivative right there, okay? This is f prime. We're going to figure out what f of x is, okay? We're going to do this one term at the time, just like we did with differentiation, okay? To this term, I'm going to add 1, which means I have to divide this by 4. So that becomes x to the 4th over 4. To this one, I'm going to remember that just an x actually means that it's x to the first. So I'm going to put a little 1 there. And I'm going to do the same thing. I'm going to add 1 to that understood exponent. That gives me 2. And I'm going to divide by 2. So now that's going to become 3x squared divided by 2 and then plus c. And I'm done. Okay? Number 6. All right? Simplify before you take the derivative. Okay? So I am going to change this quite a bit actually. Okay? Because I've got to get this somehow in the form of x to the n. And it's okay if I have a coefficient in front of x to the n, but I got to get this in the form of x to the n. Okay? So I am going to square both of these. And then I am going to bring x squared up to the top of my fraction and make my 2 negative. The 1/9, I can just leave it out here in front. Okay? Or if you don't want to write it that way, you can bring it out here as a scalar. I don't really like that sometimes. It depends on the problem I'm doing. But I tell you what I would do here is I would probably just leave it over 9 because that's the same thing as 1/9 times that. Okay? So either one of those ways is fine. If you need to see those ways again, just rewind the video. Okay? So I'm going to add 1 here. That's going to give me a -1. And I have to divide this by -1. So I'm going to bring that down to the bottom, a -1 down to the bottom. To divide with. Well, 9 is already on the bottom, so I've got to multiply that 9 times the -1 that I bring down to the bottom. So my capital F of x is going to be x to the -1 over -9 plus c. Now I'm going to show you some different ways, a different way that you would probably see this written on a multiple choice test. Okay, they would probably clean this up and make it -1 over 9x and then plus c. Okay? Alright, now this problem right here is one of the most missed questions that I see on quizzes and tests. Okay? What you've got to do is you somehow got to take this and you got to change it to a whole bunch of terms that are in the form of x to the n. Okay? That's easy to do, you guys. All you have to do is divide each term by x to the 4th. You're going to divide x squared by x to the 4th. Divide 2x by x to the 4th. Divide 3 by x to the 4th. Okay? I'm still simplifying. That's why I'm bringing that integral down because I haven't integrated yet. Okay? So this becomes x to the -2 plus 2x to the -3 minus 3x to the -4. Alright, now that I've got all my terms in the form of x to the n, now I can integrate. Okay? So I'm going to add 1. -2 plus 1 is -1. Add 1 here. -3 plus 1 is -2. Add 1 here. -4 plus 1 is -3. And I'm going to clean everything up. So this right here gives me -x to the -1. This gives me -x to the -2. This is going to give me positive x to the -3 plus c. Okay? And then this may get rewritten as -1 over x minus 1 over x squared plus 1 over x cubed plus c. Okay? Alright. Let's see what's happening over here. Okay, number 8. All right, integrating square root of x plus 1 over 2 square root of x dx. Change these to the form of x to the n. Okay, so I'm integrating x to the 1/2 plus, I'm going to make this x to the 1/2 and bring it to the top, so that's x to the negative 1/2 over 2. Okay, so now I can integrate. I'm going to add 1. That gives me 3/2. Add 1. Adding that together gives me 1/2. So I need to divide by 1/2, so I'm going to bring it down here next to that 2 and multiply it. So capital F of x is equal to x to the 3/2. Dividing by 3/2 is the same thing as multiplying by its reciprocal 2/3. Plus x to the 1/2. And 2 times 1/2 just gives me 1, and then don't forget the plus c. Okay, this is correct. Multiple choice answer. They may or may leave it that way. You may see it written as 2 times the cube root of, I'm sorry, not cube root, square root. Square root of x cubed all over 3 plus the square root of x plus c. And actually the square root of x cubed may even be simplified to 2x times the square root of x over 3 plus the square root of x plus c. Oh, and this is what really gets crazy. Ready? You have a common factor of square root of x. So 2x over 3 plus 1. Oops, plus c. Okay? Yep, I've seen a lot of different crazy things, okay? So you might see any of those things right there. Alrighty? Okay, let's go over to number 9. Now this is when you're going to want to refer to what's going on page 244. Okay? 244, right now it shows you, okay, I'm going to make a note right here to refer to page 244. Okay? The only trig rules you know right now is to go backwards. Okay? Like for instance, I know that if f of x is equal to sine x, then f prime is cosine x. Okay? For that reason, what I would know is that if I'm integrating cosine x, then remember you're just asking yourself, or you're saying to yourself, cosine is the derivative of what function? It is the derivative of sine. So the integral of cosine x would be sine x plus c, because you're going backwards, okay? And right now, going backwards like that with your trig rules are the only trig rules you know. There will be others to come, trust me, okay? But right now, those are the only ones you're going to use, okay? So let's see what's going on right here. So I'm looking at number 9, and I'm knowing what I just said, and I'm like, wait a minute. We don't have a differentiation function that says that the derivative of something is all of this mess, okay? This is when your identities come in handy. What you're going to have to do is take this and use identities to simplify it down to one of your trig derivatives that you've got, okay? So let's see how that's going to happen. All right, what I would do is I would say, well, 1 minus cosine squared is the same thing as sine squared. That's because sine squared plus cosine squared is 1. Okay? That's still not a trig derivative right there. Okay, so I would say, well, I can split sine squared, and I can make this cosine x over sine x times 1 over sine x. Okay, I'm still simplifying. In this video, anything that I write in blue means I'm rewriting or I'm simplifying the integral before I integrate. And then anything in pink will actually be the integration part. Okay? Cosine over sine, isn't that the same thing as cotangent? And 1 over sine is the same thing as cosecant. Okay? This is one of your trig derivatives. So what you need to do is ask yourself, well, what is this the derivative of? Well, if you look at page 244, the left-hand column, you have all of your trig derivatives listed there. And one of those trig derivatives that's listed is actually negative cosecant cotangent, and that's the derivative of cosecant. All right, well, I don't have a negative here. So what I'm going to do is I'm going to say, well, cosecant cotangent is going to be the derivative of negative cosecant x, because this didn't have a negative in it. So I had to put a negative to I had to put a negative down here with my f of x, and then plus c. Okay, again, check it going backwards. Okay, what is your derivative of cosecant? Well, it's negative cosecant cotangent. Take the opposite of that, you get positive cosecant cotangent. You see what I'm saying? Okay, so that would actually be your answer there. And before we got it, we actually had to do a trig proof. We had to use our identities to simplify it so that we could use one of our rules, okay? I know y'all love that problem, okay? You loved it so good you just want to see another one, don't you? Of course you do, okay? All right, here, again, this is trig, and when I wrote that, I forgot to put my dx. Let me try that again. There we go, all right? So we've got a trig function right here. So secant times tangent minus secant. This is the derivative of something, okay? But it's not one of my trig derivatives that I know. So again, I've got to simplify all of this. I got to figure out, well, what am I going to do, okay? So let's simplify it by multiplying it out. Secant times tangent minus secant squared x dx. And now what you'll see is you have two terms. Well, oops, didn't mean to write that in blue because I'm about to take a derivative. Well, that in pink. There we go. All right. So your derivative, okay, secant tangent is your derivative of secant minus secant squared is your derivative of tangent, and then plus c. See, so you're just going backwards is what you're doing, okay? So you've got to know those trig derivatives very well, all right? Let's go to number 11. Okay, so now we're going to get into some problems that we do with some of this integration. A particular solution, f of x, given the differential equation that dy dx is equal to x squared minus 1, and we're going to go through this point. Okay, so what we're doing this time is we actually are going to figure out what that plus c is. Okay, and we do that by knowing what the derivative of f was and the point and a point that f went through. Okay, so this is your derivative of f, and this is a point that f goes through. All right, so to set this up as an integral, what we do is we get dy by itself. Okay, And I'm going to do that, since this is dy over dx, I'm going to multiply both sides by dx. And that gets that dy by itself. And that gives me what I'm going to integrate right here, which is x squared minus 1 dx. So y'all see why the dx has been on the end of those integrals now? Because now what I'm about to do, so that I can figure out a particular solution, is I'm going to integrate this side and integrate that side. Okay? This gets interesting, okay? This is sort of like the integral of 1 dy. And if you refer back to page 244, when you take the integral of a constant number, you just take that number and you multiply it by the variable that you're integrating with respect to. And over here, we're integrating with respect to y. So what I'm going to do is I'm going to take this 1 right here, and I'm just going to multiply it by y. And 1 times y is going to give me y. And then I'm going to integrate over here. Okay, I'm just going to integrate each term. So I'm going to do x squared. So that means I'm going to add 1 and divide by 2 plus 1, which is 3. So that becomes x cubed over 3. And then I am going to do the same thing that I did right here with my 1. I'm integrating a 1 with respect to x. So my rule for integrating a constant means to multiply my constant times the variable in which I'm integrating with respect to. So 1 times x, which is going to give me x. Okay? And then I'm going to put my plus c. All right? Now, you're probably wondering why I didn't put my plus c over here. I'll show you, okay, what I did in my head, okay? When I integrated this, I actually was thinking y plus c, okay? Well, I'm adding a c here. I'm going to call that c sub 1. I also added a c here. I'm going to call that c sub 2. Well, if I want to just solve this for y, then wouldn't I have to subtract this constant from that constant? And when I do that, what happens is this constant minus that constant just gives me some other constant number that I still don't know what it is. So it's just a plus c. So a little shortcut from having to do this, having to put a c sub 1 on this integral and a c sub 2 on that integral, and then subtracting them, is to just put it on the x and not the y, okay? But you still need to understand what was happening right there, okay? So right here, what I've got is, this is just called a general solution, okay? All right, so that's just a general solution, and they want a particular solution, okay? What this is actually giving me is a family of functions. Okay, that's a cubic function, so I know it kind of looks like this. Okay, all right, but that is just telling me, well, until I know what c is, it could be any of these functions right here. Okay, and if you remember with a polynomial function, c is your y-intercept. Okay, so c could, right, with this family of functions, c could be any of these. And I have infinite solutions. So that's why we call it a general solution, okay? Is because it's really giving you a family of functions that look like this. C is going to narrow it down to just one of those functions. It's going to tell us, that we're somewhere along in here, maybe, or something. I don't know. We'll see what happens when we work it out, okay? So we have this general solution right here. Now we're going to find the particular solution. Well, the way we do that is we're going to now use the ordered pair that they gave us, negative 1, 3. Because they said that whichever one of these functions is the actual function I'm looking for, then that's the particular function. Because I'm being particular now. I don't want a whole bunch of infinite functions. I want to bring it down to just one of these functions. Okay? So the way that I do that is I'm going to use this ordered pair in this equation, and I'm going to solve for c. So my ordered pair says that x is negative 1 and that y is 3. So I am going to put 3 in the place of y and negative 1 in the place of x. And I'm going to solve this equation for c. So if I say 3 minus 2/3, that's going to leave me with 2 1/3, right? So, or you can leave it as 7/3, whichever one. So once you know what C is, now you can come back and put it in the place of C right there, and that will tell us that our particular solution is x cubed minus x. Ooh. Not over x, Ms. Letchworth, x cubed over 3 minus x, and then plus 7/3. And this is my particular solution. And it's just that easy. Okay? All right, let's take a look at number 12. We're going to do the same thing. We're going to find a particular solution. So, remember, you're going to get dx by itself. So we're going to multiply both sides by dx. I'm sorry, get dy by itself. So that gives me dy is equal to, let's go ahead and write this as x to the n. So that would be negative x to the negative 2 dx, right? Okay. Integrate both sides. Remember, this is an understood 1 dy. And when you integrate 1 with respect to y, you're integrating a constant. So you're going to say 1 times y, which is y, plus c sub 1. I'll do that part again. Okay. And then when I integrate right here, I'm going to add 1, which is negative 1. So I have to divide by that. So negative divided by negative, that becomes a positive x to the negative 1, and then plus c sub 2. Okay? And again, you don't have to do this part. I just did it again to make you understand, you know, why when you do this, you can just say this is y, and then just put a c over here. And that's going to be 1 over x plus constant minus a constant is still some other constant. Okay, so here's my general solution, and to find my particular solution, I'm going to use this ordered pair. I am going to put 1 in the place of x and 3 in the place of y. So that tells me that c is 2. So my particular solution will be y equals 1 over x plus 2. Okay. All right. And remember that general solution, that is a family of functions. All right. Let's move on here. Just got a few more. Okay. All right. Number 13. It says find f of x if f double prime of x is x squared, f of 0 is 6, and f of 0 is 3. And I forgot to put something in there. And that would be that. Yes. F prime of 0 is 6. There we go. Put that little accent mark in there. All right. So what we're going to do is we're going from f double prime to f. So how many times do you think we're going to have to integrate? Did you say 2 times? Very good. Yes, that's exactly what we're going to have to do. Okay? All right. So I'm going to integrate f double prime. Now, when I integrate f double prime, what I'm going to get is f prime. So f prime of x is the integral of f double prime of x dx. Okay. So it looks like f prime of x is going to be x cubed over 3 plus c, right? Okay. Now, before we can figure out what f of x is, I need to figure out what c is right here. So that's where I use this ordered pair, 0, 6. Okay. So I'm going to put 0 in the place of x. And I'm going to put my 6 in the place of y. F prime of x is my y. So it looks like 6 is equal to c. So that means that f prime of x is x cubed over 3 plus 6. Okay? So now to get f, I need to integrate f prime. Alright, so now to figure out what f of x is, we are going to integrate what we just got for f prime. And that was x cubed over 3 plus 6. So f of x, when we integrate this, I'm going to add 1. That gives me 4. So dividing by 4 means I have to multiply that 3 by 4 down here. So that gives me x to the 4th over 12. And when I integrate a constant with respect to x, then I just have to say 6 times x. And then plus c. Alright? So now I'm going to use this ordered pair right here that is on f to figure out what c is. So in the place of my x's, I'm going to put 0. In the place of my y, I'm going to put 3. And so it looks like c is 3. Okay? So that means that f of x is equal to x to the 4th over 12 plus 6x plus 3. Okay? And that's a fun little problem to do. It's more fun when you do it with trig though. Let's do trig. Yes, yes, yes. I don't like to disappoint. I know you love some trig. Going to do the same thing. We've got to figure out f of x. We know f double prime of x. We know a point on f prime, and we know a point on f. Okay? So, to figure out what f prime of x is, we have to integrate f double prime. You're going to go backwards here now, because it's trig. That's the only way you know how to integrate trig right now is to go backwards. Sine is the derivative of negative cosine. Okay? That's because the derivative of sine is negative sine, but because this is positive sine, we got to put our negative on the cosine. Plus c. Okay? Now, to get our particular solution, we're going to use this ordered pair right here, 0, 1. So 0 in the place of x, 1 in the place of y. So 1 equals negative cosine of 0 plus c. Well, got to know your unit circle. The cosine of 0 is 1. We're going to make it negative. So it'll be negative 1. add 1, and C is 2. So f prime of x is negative cosine x plus 2. That's not what I wanted to write. Now we're going to find f of x. We're going to do that by integrating f prime of x, negative cosine x plus 2 dx. So f of x, okay, so negative cosine, okay, cosine is the derivative of sine, but because it's negative, I'm going to have to put the negative on sine. And then integrating the constant with respect to x, you just say 2 times x, and then plus c. Okay, so now using our ordered pair of 0, 6, I'm going to put 6 in the place of y, and 0 in the place of x. So 6 is equal to the opposite of the sign of 0. Well, sine 0 is 0, and the opposite of that is still 0. So all that right there works out to be 0. And then 2 times 0 is still 0. So 0 plus 0 plus c is just c. So c is equal to 6. Okay? So looks like f of x is negative sine x plus 2x plus 6. Okay? So with these you can tell, you know, that you are going to have to do the whole finding c thing first and get all the way back to f of x, because you're starting with f double prime and you're just going backwards now. Okay? Alright, just a couple more, 15 and 16, and we are done. Okay? This is a nice little problem. This is going backwards, but if you notice, you're actually getting 2 points on p, and neither one of them tell you p prime. But that's okay. We can still use this because this is your derivative of p with respect to t. So we're not going to be going through double prime and all that like we were in the other one. Okay? But what we do have to do is we have to take this, what we call that derivative is referred to as differential equation, multiply both sides by dt, and what you get is dp is equal to k times the square root of t dt. You're probably thinking, well, what is that k in there? Well, k is some scalar, okay? And we don't really know what that scalar is. It represents some kind of number. That's all we know. I know that it's a number and not a variable because you will only have 2 variables when you do this, okay? One of them is p, the other one is t. Alright? So k has got to represent some kind of number. So when we do this, we're just going to treat it like a number. So I'm going to integrate both sides. Alright? And when I do, then this is just going to give me p. You're probably used to that by now. Okay? And here, this is like t to the 1/2. Okay, so I am going to add 1 to this, which means I have to divide by 1/2 plus 1, which is 3/2. Now let's clean this up. Dividing by 3/2 is the same thing as multiplying by 2/3. And I'm multiplying k times t to the 3/2 plus c. Okay, so that's what I get for p. Now I've got to figure out what c is. Alright, so I'm just going to use my first ordered pair that they give me, 0, 500. And in the place of x, I'm going to put 0. In the place of the p, I'm going to put 500. I don't even have to know what t is here. I'm sorry. Yes, I do. T. It's t. T is 0. K is some number. I just got that out of my mouth, didn't I? K is some number. I'm sorry. It's t that is 0. Well, if you multiply all that out, that's going to become 0, and c is just 500, right? So what we get now is we have the equation P equals 2/3 K times t to the 3/2 plus 500. Okay? So, I know what C is. Now, what I really need to know is what K is. Because I've got to figure out what this function P is. That's the only way I can figure out P of 7. So that's where the next point comes in handy. Okay? You're not integrating anymore. You're done integrating. Okay? From here out, it's just pre-cal stuff. Okay? Because everything is P, right? P of 0, P of 1, P of 7. We know what P is. P is this function. We don't know what K is. So the second ordered pair is going to help us. I'm going to take that second ordered pair. In the place of T, I'm going to put 1. In the place of P, I'm going to put 600. I'm going to figure out what K is. So 600 in the place of P. Don't know what K is. But in the place of T, I'm going to put 1. So 600 is equal to, all of that is 1 times 2/3 K is just 2/3 K plus 500. Subtract the 500 and multiply both sides by 3/2, and K is going to be 150. Now that I know what K is, then I can figure out that P is 2/3 times K times T to the 3/2 plus 500. So P is equal to, what is that going to be right there? 300 divided by 3 is 100. T to the 3/2 plus 500. So if I want to know what P of 7 is, I'm just going to put 7 right there. Okay. If I didn't have a calculator, I would stop. If you do have a calculator, then, and most likely this would be on the calculator section of a test, then that's what you get right there. Okay? Alright, last question. A little integration here with PVA problems. Given that the acceleration with respect to time, or acceleration over time, is equal to negative 9.8. That means you're accelerating at negative 9.8 meters per second squared. How long will it take for a ball to fall 1,800 meters? Write an equation for h of t. So if you remember PVA, PVA, when you differentiate, you start at position, and where this is F prime, F double prime, and you go this direction. But when you integrate with acceleration, then you integrate acceleration to get velocity and velocity to get position. Okay, so since they want us to write an equation for h of t, we're going to integrate a of t. But I need to know some ordered pairs, just like I knew over here. If you come back to this problem, when they gave us the second derivative, and acceleration is the second derivative, I had a point for the first derivative, and I had a point, and then I had a point for the function. So if they're going to give me acceleration, which is second derivative, I need a point for velocity, which is first derivative, and I need a point for position. And that problem tells me everything I need to know. It sure does. Okay? So let's figure that out. Let's go with v sub 0. Okay? That means your velocity at 0 time. Well, at 0 time, you're not even moving. So if you're not moving, there's no speed. So v sub 0 is 0. Okay? H sub 0, your height at 0 time. Well, it says how long will it take for a ball to fall 1,800 meters. So that means it must be up 1,800 meters. Its height must be 1,800. Okay? So here's your ordered pair for your first derivative, and here's your ordered pair right here for your second derivative. Okay? Because this is the same thing as a prime of 0 is 0. Not a prime. Gosh, Pamela. Let's get it right, girl. H. Okay? H prime of 0. Okay? And of course, A is your H double prime. Okay? Alright? So we've got what we need to know right here. So let's integrate acceleration. Alright? So, V sub t means you integrate A sub t dt. So your velocity means we're going to integrate negative 9.8 dt. Well, that's a constant, so all I have to do is multiply that constant times t, and my velocity function is negative 9.8 t. Okay? Plus c. Using this ordered pair right here, I'm going to figure out c. Put 0 in the place of your y. Put 0 in the place of your t, your x value. So c is 0. Therefore, v of t is simply negative 9.8 t. There's our velocity function. Okay, we've got to get to our height function because it asks us to find h of t. Well, h of t means that you're going to integrate v of t, right? So h of t means we're going to integrate negative 9.8 t dt. So I have an understood exponent of 1, so I'm going to add 1 to that and divide by 2. That gives me negative 4.9 t squared plus c. Now I need to use this ordered pair to figure out what c is. Okay? So 1,800 in the place of h and 0 in the place of t. So c is 1,800. Yes, you could have done this without integration. No, I'm not going to let you, not on this part. You got to learn how to do it because it doesn't always work out this easy. There, we settled that, so no more discussion. Love you, mean it. Yes, I do. Okay? So that means that h of t is negative 4.9 t squared plus our c, which we just figured out is 1,800. Okay? Now there's your equation, but we still have a question to answer. If you go back to up here, it says how long will it take for the ball to fall? That means we've got to find time. Okay? So we've got to figure out how long it's going to take the ball to fall. Well, when the ball falls, what is its height? It's going to be 0, right? Okay? So, when the ball falls, h of t has to equal 0, meaning it has no height anymore. So we're going to put 0 in the place of height. And we're going to solve this equation. Time is going to be positive, so we're just going to take this positive square root of all that stuff right there. Okay, if I didn't have a calculator, this is exactly how I would leave it. With the calculator, I would know that that's going to be about 19.166 seconds. And with that, we are finished. And remember, yes, I heart you. Okay?